Start recording. Okay, so we are recording now. Um, I'm gonna minimize
Yeah, cool.
this. Maybe we'll just start with the intro. You want me to do a
Sure.
quick intro? Yeah, and I was just thinking today is just like what's the landscape of WASM? So like part of that is like what is WASM? Uh, how do you generate WASM? How do you consume WASM? Like what sort of just exploring that would be helpful for me, and then also like how what you've learned from making your own WASM language. Could be a separate chat or tying that like what you've learned from that into this would be helpful for me, for maybe other people as well.
Yeah, cool. Yeah, I
Anything
think
else before
I
I
think
start the intro?
um no, I think that sounds good. Yeah, I think it's trying to find like the practical side of WebAssembly because it's like definitely a good catnip for like nerd sniping yourself, but yeah, trying to find that sort of more practical aspect of it.
Cool. Okay, I'll do the intro. Um, camera. Okay, I'll start. Three, two, one. Hello. This is Chris, and today I got Patrick Smith with me, and we'll be talking about the landscape of WASM. It's something I'm starting to dive into, and something that Patrick has probably a little more or a lot more experience than me. And Yeah, I think I've found as I've started diving into it, there's a lot going on. There's a whole set of standards around WASM that you have to learn, and then there's different tool chains to generate WASM and different ways to consume WASM. Uh, there's also new standards that just landed last month or even less than a week ago around the component model and WASM GC and WASI Preview 2 and like uh, so yeah, this is sort of just us trying to like figure out what the landscape of WASM is. Um, yeah, I don't know if you want
Yeah,
to say
cool.
hi,
Yeah.
Patrick, or
Um
uh,
yeah,
get us
g'day. G'day
started.
from Australia. Yeah, no, it's I'd like talking about this stuff so because it's I've been working on this project called Orb and it's been fairly solo, so um I find talking to people just like really cool just to bounce ideas off. Yeah, I don't want to come across as like I don't think I have like a decent understanding of WebAssembly and I don't think I understand it all. It's like a continual learning process.
Yeah.
Which I sort of see my whole career as. But yeah, I think in terms of like why WebAssembly is why I'm focusing on it is um, I see it as like a potential like one of those like core technologies like HTML or like HTTP or um,
Mm,
JSON even. It's just like one of these like I think it has the potential to become like just like a critical puzzle piece. And so for me, I like to like understand like how those things work because like you can certainly learn web development from the point of view of like I'm going to use a framework and then like understand everything about that framework and then I'm now an expert in Next.js or Remix or whatever. But then like okay, but how does it work under the hood? And
right.
like I don't need to go into like, oh, okay, I'm going to like understand how a network router works, but like just some understanding of like how things are sort of being modeled underneath. And so, yeah, I like to use that sort of approach for like learning HTML. Like, okay, how does the browser like conceptually parse and work with HTML? So yeah, sort of wanting the same stuff with like WebAssembly.
I love that. Have you? So with that framing, are you coming at like WASM is an important tool for me? Building stuff on the web. Because like conceptually, like stemmed out of like browser standards and working in the browser, but it's also much more agnostic to, you know, there's separate runtimes like WASM time and things that could run WebAssembly on arbitrary servers or your local machine, or in games, just to name a few. So it's like, don't let the name like deceive people into thinking it's only for the web. But like, have you found it most useful for the web, or are there other uh, cases, as you've been like exploring orb and stuff, like where you found it useful outside of the browser?
Well, I'm really trying to get Orb to an alpha stage and get it out because it's like one of these things where it's like I gave a like talk on it last year. It's like, hey, here's what I'm thinking. Here's this project idea. Maybe you've thought about WebAssembly as well. Here's I think a way to author using it.
Mm.
But yeah, I'm really wanting to like collaborate with people to sort of work out exactly how to answer those questions because like I'm not shipping any WebAssembly in production apart from like what is it that syntax highlighter library? I forget what it's called. The one that uses the VS Code like syntax
Oh,
stuff.
Shiki? Is it?
Shiki, yeah,
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 yeah, yeah.
Shiki JS, yeah, yeah. So there's that sort of stuff where you can use like that's one of the benefits I think of WebAssembly is it lets you use like existing libraries, like existing C libraries, compile them, and then like bam, it's like working in your browser. Like people like use like FFmpeg in the
Yep.
browser or like SQLite in the browser. And it's like one of the advantages is I'm n- someone I'm sure has tried to recreate SQLite in JavaScript, but you're going to be starting from scratch. So like, why not
Yep.
use this code base that's had like a decade plus worth of investment in it? It's like the same thing with FFmpeg or yeah, some of the it's like PNG's Crush and like there was a Squish suite of libraries from Google for like compressing
Yep.
images and like resizing images. I think that's sadly a bit changed or something, but like they just like there was like a libpng and like
Yep.
libjpeg and like and then like other C libraries to like compress them, PNG quant and like all these things written in C, and it's just like cool that you can just like suddenly use it in the browser, use it anywhere. And I don't have, yeah, it's just you get all, yeah, you get that, yeah, investment, I guess, that's been put into that stuff.
Yeah, a small case I've stumbled upon in my own work is parsing TextMate files if you're doing like stuff with like Monaco editor in the browser. Um, and yeah, there's a library called VS Code TextMate, I think. Um, and yeah, it's a WASM module, parses TextMate files, and you can take that output and do something useful with it to, give it with the Monaco editor, for it to understand grammars,
Yeah.
for
Yeah,
example.
TextMate is like ancient, and it's like TextMate was this like app that I was using on my Mac like 20 years ago, and
Right.
it was like it was the new hotness back then. It was like its times VS Code maybe, but it's had like 20 years of like investment with like the most obscure like file format. There's like a syntax. There's a
Mm-hmm.
syntax definition for it, and so that's awesome. Like you can, yeah, you don't have to go. Oh crap! I need the Lua. My own highlight JS doesn't have a Lua syntax or whatever. I'm sure it probably does, but like some of those more modern ones that are like really um, well engineered, but yeah, you're just starting from scratch. So um, yeah, I think the other aspect of WebAssembly is I think there's like been a lot of push to like have JavaScript everywhere, and I'm not anti JavaScript, but I'm not a big fan of the complexity that's in
Mm.
um the sort of culture. There was an interesting tweet about culture in web development um today that I saw. So there's just okay, JavaScript is naturally going to work in the browser, and then we're like, okay, let's like, wouldn't it be cool if we could run it on the server? But
Right.
then there's just, it's not necessarily that JavaScript is complex or a bad fit. It's just that the community around it is like just full of so many opinions and churn and just like, and it's just like you just wanted to get the most simple thing running, and then you're like talking about bundlers, and you're talking about how to optimize it, and you're talking about minifiers, and you're talking about all this like stuff. And it's like kind of just wanted to have some code and have it run in two places and not worry about which flavor I'm going to be
Yes.
using. So yeah,
No, that's a
and which
great point.
sports team.
It sort of like takes you out of a pace layer that moves extremely quickly. I think that's what I find most intriguing about it. Um, is you can it helps you like escape out of that and uh, maybe
Yeah, and I
achieve
think JavaScript can still be in the picture.
yeah.
I don't think it needs to disappear, or don't. I'm not even sure if it's going to be like obsoleted by WebAssembly. Now you can run it in the browser. Like I'm not sure if you're going to necessarily just going to go. We're going to have today. I've got HTML, CSS, JavaScript. I'm just going to get rid of JavaScript, put in WebAssembly, and like now I don't have to deal with that pain in the ass language. Like I don't think it's. I think that's if some people want to have that opinion, sure, but these are just tools, and I think one of the criticisms, which I think's been rectified with how people frame JavaScript, is like when you hit a URL, like your browser makes a GET request,
Hmm.
does a HTTP request, it sends back a response, and that response, like unless you've got a weird website, it has to be HTML, like it has to be HTTP headers, and then has to be a body with HTML. And like there's just been this like culture where people want to go, no, but it's JavaScript first. JavaScript is my entry point. And I don't I think that's again, if people want to explore that area, I've got no problem with it. But I think that that's sort of limited how people think about problems. So yeah, I think JavaScript is just another player. Like you got all these different
Yep.
puzzle pieces, and JavaScript's just a useful one, and then WebAssembly is like another new useful one that could and that we're still trying to figure out what it could be used for. Um, yeah.
Yeah, I love that.
So
And it
I think in
sucks.
terms of like
Oh, sorry. It sucks when that there's this like ethos that it like it sucks you into this architecture where you're using a JavaScript framework. Well, that assumes you have JavaScript infrastructure on the back end. Maybe that's not a good
yeah,
match. A single threaded concurrent language isn't a good match for what you're doing. um,
well,
whether it's an
it's not even it's not. I'll be interested to talk about some of that single threaded stuff because it's I think I think those things are maybe a bit overrated. I don't know. Yeah, we can talk about that later. But like single threaded is fine, is a great default, and I think fine for most use cases. But yeah, we can talk about a bit about that later. It's not really about JavaScript as oh, it's so limited. Like there's definitely that aspect where there's just some code that will just run faster with the model like WebAssembly rather than JavaScript. I guess it's like um, it's just having if I want to have this like universal code and I want to run it, it's today if you use JavaScript, it usually means like
mm,
inheriting a hugely complex ecosystem. And so you could do JavaScript without that heavy ecosystem, like the Basecamp group get, are good at marketing a story around that. Um, but yeah, I just Yeah, I think for me, partly just trying to get away. People joke about the JavaScript fatigue sort of thing. I think WebAssembly is just a nice way to just do a little bit of a reset, and it's
mm.
not saying, "Well, this is the way it should be." It's just like, okay, if I just sort of start from the ground up and then think about what I need. Yeah, I've been enjoying exploring that.
Gotcha. Cool. Yeah, no, that makes a lot of sense. I like the mindset you're coming at it with. It's not like uh, winner take all environment, right? Did I lose you? I think I lost Patrick.
Yeah, still got the canvas. Yeah, should we jump into that? Yep. Yeah, cool. Well, there's a number of different ways of doing it, but I think this is probably just how I think of code anyway. Um, let's start with that. So I've just added the word single responsibility, which is a bit of um, a, a popular word. Um, so yeah, there's this idea of like single responsibility. I'm going to create this like piece in my code, and then it's going to be like responsible for something. And then people usually try and say like, well, should have a single responsibility. And like to be honest, like that's where to me that's the art of writing software is that it's all actually subjective. Like there's people like to come up with like rules for like this is the way it should be, or if I'm going to define a class, then here's a recipe I follow. But I find that stuff, that stuff can be helpful, but yeah, I think it's all subjective. I think if you gave five devs the same problem, it might have a similar shape, but they'll solve it slightly differently. So, yeah, so you've got this idea of this thing that's like responsible for something, like some sort of logic or some sort of state. And then there's like, I've got an arrow moving in, so there's like something that like wants to talk to it. Um, so they've got this thing that like wants to talk to it, and then our module is going to like talk to other stuff.
Mm,
And so if you've got like object oriented approach, then like this thing's like a class, and
right.
then like maybe the thing that I talk to, I like pass to like the initializer or like the constructor in JavaScript. Like this is my database or whatever. So I might talk to the database, and then the things that want to talk to it are like my like controller or root component or like whatever my router, whatever it is.
Yeah.
Um, yeah, just this conceptually, like I'm zooming into like a particular problem at this point here, um, and I'm sort of going to carve stuff up, and generally things are going to want to talk to me. So that's like my public interface. This is my like API, um, and then down here is like the like calls to other stuff,
Mm,
and I'm going to talk to other stuff that I've probably been given to me when I was first created, or maybe I look it up dynamically. Maybe there's a singleton. Maybe
right.
I'm importing from in JavaScript like a module, and then I talk to the thing.
Mm,
Maybe I use context if I'm using React, whatever
right.
it is. But somehow somehow I grab a handle to it, and then I can talk to it. Um, so yeah, that's how at least I think about stuff, and and that's where like naming is one of the hardest things. It's like um, you have to like name this thing. So you have to give this thing a name, and then you have to like design the API, and you have to give those things a name, and then you're going to talk to other stuff, and you have to give those things a name, and then they're going to have APIs, and so that they're going to have their own names. And so this is what I think of like when people say naming, because when I first heard like naming is that one of the hardest things in computer science, I was like, what are you talking about? Like, and so this is how like I interpret that. Like, okay, like the mental model of how I break this stuff down. That's the art. That's the hard stuff.
So
So
where does WASM come into play here?
yeah, so if I take WebAssembly and then I'm just literally going to duplicate this over,
Mm.
WebAssembly is a model where it's literally we call this the WebAssembly um, instance is probably the best way to call this.
Is
We're
that
going to have this
synonymous with
idea of
a WebAssembly module? Are you
yeah. So if
are those
let's call it
interchangeable? Okay.
so WebAssembly. I'll call it. Let's do WebAssembly module because I'll have an analogy for that.
Okay.
But yeah, we've got this idea of a host. So the thing that it's going to talk to us, we call it the host. And then the thing that we're going to talk to is called the import.
Mm.
And so,
So an example of the host is like the browser, a JavaScript engine
yep,
that's
yep,
you know communicating with a WebAssembly module.
yep, yep. Web browser, probably by like JavaScript. Let's make these a different color. It might be
Server.
like HTTP,
Mm.
like request response handler. It might be like a command line app.
Yeah.
It might be,
Could be a game.
uh,
Video games that have like a
yeah,
WebAssembly
yep,
plugin system. I think that's like a really
yep,
big use case.
yep. Yeah, game could be yeah some sort of plugin system, whether it's games or not. Like there's some stuff where they use it for like some systems are using like WebAssembly plugins, and so if you implement their API, it doesn't sort of that's the cool thing. It doesn't actually care how
How you
your
write it.
WebAssembly was created. It could have been written in Rust or
Yeah.
whatever else, but as long as you sort of meet this contract, then you theoretically can just like plug it in. Um, what else? There's some like WebAssembly um, like hosts, like web hosts.
Mm.
Um, um,
It's
so
probably a
yeah,
good list.
generally I think yeah, and so generally I think of this as like you're not going to necessarily come to WebAssembly going, I'm going to go WebAssembly first, and then I'm going to try and work out how to use it. Like generally, I think you're going to be solving some existing system. Oh, I'm making a game.
Yeah.
I'm writing a website. I've got a HTTP server. I've got a command line app, and then I think you're going to still write all um, that code and use a framework and existing system for that. But then I think you're going to plug in a WebAssembly module or modules. Oops, plug in a WebAssembly module um, into that system. And so that's how I'm approaching this. Whereas I think again, I'm trying to like avoid absolutes, but I think maybe there's a stream of like I'm going to write everything in WebAssembly, and I think that's like really ambitious and going to be a hard sell to organizations, and you're going to have to like reinvent a whole heap of stuff to
Right.
do that. So yeah, I think there's all this stuff. I want to make an HTTP request. I want to have a web server. Like I don't think there's that much use in reinventing that from scratch unless it's like an academic exercise. Um,
Right. Its value is in portability and
yeah,
extensibility, I think. And what that
Yep.
means is that it doesn't run. It can run by itself, but the point isn't to recreate the world in WebAssembly. It's to use WebAssembly as um,
Lingua franca. It becomes
as a
a
center, as
common.
a central protocol for all these other things
Yep.
that that could integrate with it.
Yep. Yeah, so yeah, exactly. And I'll just to finish the terminology here, this is called exports,
Mm-hmm.
and these are called imports. So it's sort of quite similar if you're familiar with like JavaScript, the modern JavaScript world. I'm going to duplicate this thing. We're going to have like my JavaScript app with
Right.
ES modules, and then it's going to like import. I hate using foo, but I'm going to say
Yeah. Yeah. Yeah.
import foo from my module, and then like, okay, how is this going to um, let's get rid of these ones. But it's going to go import foo, but how does it in my module we're going to say like export foo. So there's this like natural if you're familiar with JavaScript, there's this that
Yep.
sort of one thing's import is another thing's export. And then like this thing's going to like also like import um maybe it's a library. What's the my mind's going blank. What's
Like,
underscore
yeah.
or Lodash or I mean I
Mm-hmm.
want to get encourage people to get away from Lodash. Just like any library,
Yeah. Yeah.
some
Yeah.
lib
I got. Yeah. That makes sense.
from some lib and in import um inner stuff, like internal stuff
Mm.
from a deep directory or something like that. So yeah, applied the same sort of thinking. Sorry, this should be what we
ES
call like
module.
an
Yep.
ES module. um, so yeah, my JavaScript app is basically today how we author it is like a bunch of files. All those files are ES modules like .ts maybe if you're using TypeScript. And then all those files are just like basically sitting there. And then how they're all like linked together is with these import export statements that when we read the code, we go, oh yeah, that's how these things relate. But at the
Mm.
end of the day, it's just sort of a made up system. Um, but yeah, you got this idea of this ES module like exporting some stuff, and then other stuff's going to import it. And then the CS module could stand alone, could be like the leaf node, or it could be like it could be a middle manager, and like it's going to like import other things to
Yep.
do its work.
Yeah. That makes
Um,
sense.
so yeah, you'll see like this. This is just my thinking. This like I like really simple mental models, but you'll see like these sort of these things repeated again and again and again. Um, yeah. And with all of them, the thing that they all share is that you have to name these things, and that's the art of software. It's like, okay, what do I, my module, what do I call it? This file name.
Right. Well,
It's exporting something. What do I call it? Blah blah blah.
so in maybe to continue the metaphor in JavaScript, you can export classes, you can export functions, you could export variables like just a const. You could export a let variable as well. Um,
Yep.
any other number of things. Those are the core things I feel like are usually exported though. What does
Hmm.
that look like for a WebAssembly module? That's a question I have. Is it only functions, or
Yeah. So
can you export other things?
yeah. So that's an awesome question. So you asked before, like, there's this thing called a WebAssembly module, and then there's this thing called a WebAssembly instance.
Mm-hmm.
What's the difference? Why do we have these two names? hey, you just want to run some WebAssembly. I don't care what it's called. So how these things break down is that I think of this thing as like a class, and I think of this thing as like an instance of that class,
Right.
which we usually call an object. But like, so it's like class foo, and then this is going to be like const
New
o
class. Yeah.
equals new foo. And so we can create many versions of like foo again and again and again. Um,
Yep.
I'm just going to add the parens because that's how people are familiar with doing it. I think the parens are technically optional, but
They are. They
so
are.
you can define this thing once, this like useful piece in your big puzzle, in your big app or whatever you're building, and then you can like create multiple versions of it. So
Mm.
yeah, so you can define a WebAssembly module once and then instantiate multiple instances of it. And um, so yeah, you're asking about like, okay, like, hey, like normally when I grab a export, I can export a const, I can export a let. So like you've got this idea of like mutability. Um, it's sort of the same question here. So like I could go like new foo, and then I can go like, hey, probably better to have a more concrete example, but I could say like, hey,
The counter.
increment or
Yeah.
whatever.
Let's say we had a
Yeah,
counter module.
yeah, yeah, yep. Class counter. Just gonna scroll down so we can bit more space. Yeah, class counter. As we know, it's going to have a bunch of stuff in there.
Mm-hmm.
And then we create a new counter, and then we ask it to increment. And so then maybe we can like go like, hey, what's the current count? And it says like starts up as one and then becomes two.
Right.
And so we can ask it straight after creating it, like, hey, what's your count? And it's like one. And then we tell it to increment, and then it's yeah, turns out it's incremented. So like this counter thing, this counter object, or this counter
Mm-hmm.
instance is often used in like object-oriented programming. You've got an instance of a counter. It's mutable, so it's got some state, and you're able to change that state. And how you get access to that state is through the counter's like methods, which
Mm-hmm.
is so through its like API. And so that state is available to me, like however that class or however that object decides to make it available. Like if it deleted the count method, all I could just do is just like increment it and have no idea what happens. But like usually you want to have like um yeah, you probably want to read and write. So here we're reading, here we're writing. Um so it's encapsulated the state, and it's controlled access to the state. So for example, if this thing never exposed a decrement method, then
Mm-hmm.
we just couldn't, as an outside user of the counter, we couldn't make the count go backwards. So it's controlling that state.
Gotcha.
Um, and that's really important because, um, you know, we might be able to, in a lot of languages, you can like, and including in JavaScript a lot of the time, you
There's
can
no
get
protection.
access to the sort of, yeah, you can sort of get access to what's inside the counter and then like mutate it behind its back, but it's usually like it's going to bite you.
Yeah.
Um, yeah.
Okay. So some
Uh,
questions here. If let's say I'm writing compiling WASM from C, count,
yep.
and we have a counter WASM module or instance. Count from an implementation standpoint is also a function. It's like a getter. Is that correct?
Yeah. So in terms, I'm going to try and do this the best off the top of my head, but if we've got a C program, let's go counter.c. Uh, as far as I know from memory, we're going to you'll have like the concept of an extern function. So we're going to have, I think that's right.
It depends how you're
That's no, sorry,
compile.
I'm actually confusing myself. That's for an import. So no, we're going to have like an increment function.
Yeah. So in Scriptum, which is a way you can compile to C, they have their own little macro. So it's
Yeah,
keep it's not keep alive, but it's like pretty much saying don't get rid of this function. This function is an export.
yeah.
Or you have to specify it in the command line. Uh, in the command line, like these are the functions that are exports. That's how
Okay.
you at least within in Scriptin. I know Zig can also compile C to WASM, but I forget
Hmm.
how you define like your exports and your imports. But yeah, so it would look
Yeah, I
just
think
like this with some kind of like macro up right before it.
yeah, C is really extensible. So often, like you never really just use plain C. Like there's some sort of like compiler magic
Yeah.
pre-processing extra flavor added. So yeah, they probably needed to do that to map it to the WebAssembly world. But yeah, like in JavaScript, you've got this idea. Well, in type, it's sort of you could have inside my class counter. I could have an increment method, right? And I think I can just say
Mm-hmm.
public increment and it does whatever.
Yeah.
But I could also have a private. Maybe I
Mm-hmm.
decide to have the decrement method, but it's like private. So this like concept of like, hey, this thing's basically accessible from the outside world, and this
Yeah.
thing's not. That's a pretty very common pattern. So, but the sort of has different ways of doing that, and so it might not map over well. Zig's better because you've just sort of basically, I think in Zig this is just called like pub,
Yeah.
and I think if you just have nothing, it's just like it's
Private.
private by default.
Yeah. Uh,
In Zig you don't have class; it's something else. But
no matter
so
how you're writing it, there you can have functions that aren't exposed that aren't exports. Like
yeah,
that's a
yeah, I think that's really
choice.
useful for backwards compatible for not having breaking changes because you have to be very mindful of
Yeah.
what am I making public a public API or what am I making a private API. If everything's public, then it makes it hard to make changes in the future because ah crap, I kind of want to get rid of that method, but someone was depending on it and now I can't.
Mm-hmm.
So sort of back to the sort of like concept of like single responsibility single responsibility at the top here, it's like this is like my public API.
Mm-hmm.
And so again, like in terms of like the art of naming stuff, it's like the art of like API design. Like, what should I make public? How should I model it? What was previously private, but I want to make public now? How do I restrict the sort of the outside world's view of how it can observe me?
Yep.
Um, So yeah, like yeah, anything with WebAssembly, you're gonna have to still think about the stuff. So again, it's sort of the more that's yeah, more art of software. But yeah, so if encounter, like I'm gonna be probably really rusty at C, but I should be able to have like a int count equals say it starts off as one.
Yep.
Um and this what this type is in C depends on your host, I believe. But let's just say it's
We'll ignore
int.
that. It's gonna be an int
Um
32 probably.
yeah, int 32, whatever, however whatever types I have. So yeah, it's going to be this count, and then maybe inside my code, I'm going to go like, um, it's going to,
Yeah.
count
Compass
plus
equal one.
plus plus if you want to use that
Yeah.
syntax.
Yeah.
And then I'm going to say like, hey, I want the outside world. I've decided to let the outside world like read the count, and maybe I call this like get count. Maybe that's actually the better name for this thing up here, but I'm just going to call it get count. So then, yeah, I'm just going to return count.
Yep.
So this becomes my public API, and like you're alluding to, this isn't the full picture because with mscripton or whatever, I'm gonna need extra annotations or extra things to sort of say to have like an allow list of like which functions exactly are public.
Yep. That's
But yeah, I think
regardless
if you
of
haven't,
what language you're writing, you're compiling to WASM.
yep,
Some will just have built-in syntax, likely. I guess
yep,
the other thing is a WASM module doesn't have to be stateful. It has an option, but it could
yeah,
also
it doesn't
just be
have
a
to be.
set of
No,
utility functions that hold state while they're executing and then free everything up. Uh, so
exactly.
in a way,
Yeah,
that
it
a
could
class is
be a
the class model is like a superset of just functional helpers as well.
yep, yep, exactly. Yeah, so the yeah, I'll just scroll down. We'll just keep going, I guess. But yeah, you've sort of got this idea of um, like stateless and stateful, and so example of stateless. If you've done like more functional programming, is sort of I've got this function, um, and I'm going to great example of something that's stateless is like any of the like Boolean operators. So it's
Mm-hmm.
like A and B. Like that's a stateless sort of operation. I'm not mutating A or B. It's a sort of just coming out with a new value that's like going to be true or going to be
Right.
false. Um, and so maybe it's like negative A. Like that's a very so I could export a function that's like negate number,
Right.
and I'm
that
going to
that'd be
have
pointless. But yeah, get the gist.
yeah. So that's it's and so yeah, you're probably going to want to do a bit more than that. Maybe it's like base 64 encode and something or decode.
Right. Hmm.
And so um, yeah, you can sort of start to think of like greater, bigger like computations that you might want to do. So yeah, stateless or another way I think of this as like it's just a computation, stateless computation, which sounds a bit like a mouthful, but it's such a simple concept really.
Yeah.
Um, a stateless computation and then like some sort of stateful thing. So if I call base 64 um, again and again and again, like sort of like implicit in the contract is like if I call it the third time, it's not going to act differently. And so like that's a key thing of like functional programming. I don't just like decide to encode something and that suddenly changes underneath me.
Yep.
And so where something that's stateful, like that increment thing, or there's maybe I'm computing a hash.
Mm.
So it's like add um, like what's another example?
Uh.
Yeah, often just like a digest. So it's like we've got some sort of digest, and they're going to add to digest,
Yeah. That's a great example.
and then like as I keep adding,
SQL like could
um,
be an example.
yeah, you
You
could
could
go
have
all
a
the way to
database.
SQLite. Yeah,
I think the next question that comes up is how do WASM modules hold state, right? There's some
yeah,
really important characteristics around sandboxing and security, also simplicity at the moment. It might
yeah,
be worth talking about that, and then also, we've sort of talked about like WASM, but we haven't talked about like it's a binary format, and then there's also a textual format called WAT. In those, like, there's only like a couple class types, which are just numbers. So everything is represented as a number. That's how like the compilation works,
yeah,
which is interesting. What's more interesting in the question that I am still figuring out is, let's say you're returning a struct from this counter. Um, how is that passed through the WASM boundary into the host language, and vice versa? Like, is everything just numbers because those are the only first class things in WASM? Uh, yeah, like obviously, I think a string, like strings are like pretty. String representation in C is likely different than whatever the host environment is. How does that work? It is that something I don't know. Is that something you would want to
Yeah,
dive
so I
into?
had
I have a lot of. I think that's like such
yeah,
an
so
important crux of that boundary is such an important crux of also like that is being copied. It's not being shared. That's another
yeah, that's right.
important. I don't
Yeah,
know.
so
All those are really
the
related.
yeah, I think yeah, so there's a lot there. So but I had the exact same questions. And so yeah, I created a little repo a couple of years ago where I just had these questions and it was just like literally like, okay, this example of like something stateless is I'm just gonna have like um can you see my screen by the way?
One second. I can. Let me make it big. No, I don't see your screen being shared.
Oh, I need to it's because the Discord dropped. Okay, I'll share my screen. Yeah, let's share my screen.
Okay, I see it. It's loading. It's up.
Okay, so we've got this repo. I just called it WASM comparison. I don't know. So just
Uh,
basically created a file, and I'm just was had the same sort of questions like, how is C or how is Zig or how is assembly script? I think I tried.
yeah. Oh, some
How is
benchmarks too.
Rust? Yeah, probably. Yeah, I can't even remember. This thing's a bit. It's not very. It's a bit of a just a junk drawer. But I just had the same questions like, how does it actually represent this stuff? So hopefully you can just like kind of map this to this is Zig, but you could quite easily map this to like JavaScript ES module.
Hmm.
So I've just got like it's the same sort of syntax. I've just got like const pi, const the meaning of life is 42, const another one, and then it's like okay, how do I make if I've got this idea of this module and then like things want to talk to me, like how do I make that available? And so I can export a function to read that constant.
Mm-hmm.
So I can I'm returning pi here, returning the answer. So that very very simple. And so the one of the first things I discovered was that you can't really, at least in Zig, how they've done it, you can only export functions. You can't export like just the constant itself. As far
Ah.
as I know, there is a sort of way to do it in WebAssembly, but they sort of just give you one way of doing this thing. So all you can do is just export a function, even if it's semantically a constant. You're going to have to call it to find out what it is.
Yeah, and it could always be
Um,
inlined or whatever during the compilation
yeah, you
process.
could
So,
inline this. Yeah,
so
exactly. Yeah, that was the other thing I was trying to see is like, okay, if I like, probably not showing this, but like if I inline it versus like if I have it up the top here, like how is it deciding to make that different? And like Zig is has a pretty awesome optimizer. So
yeah,
if it can work out that this constant is only used here, it will like inline it for you. So like that's where Zig was really interesting to sort of explore. Um, yeah, here's hello. All it does is say like basically does a console log. And it's just like, okay, that's cool. I can write that code, but what does it turn into?
what
So
so
I'm
what does it
curious
turn
to see because
into?
I've
Is it use
yeah, I'm curious to
WASI
see if
or uh
I don't think doesn't look like GitHub has WASM syntax highlighting, so that's sort of a bit disappointing. Um, let's try and open this up, and none of those. I want to open it up. I'm just gonna reset VS Code.
so just to clarify, WASM is a binary format, so it's just going to be like ones and
Yep.
zeros. Are you fluent in
Yeah, it's
reading
just
that or what?
no. So that's what the
Okay.
WebAssembly. It looks like my VS Code's
Oh,
updated.
there's
Beautiful.
oh
So it
VS
looks
Code will transform it into a WAT file.
yeah, it will
Oh, cool.
that's why that syntax is so useful. Is let's just open this repo. That's why that syntax is so useful because, yeah, binary protocols are very efficient, but they're great for computers and not so much for people. So, well, so looks like I haven't pushed up some stuff. That classic. So we're looking at that constant.zig file,
Mm-hmm.
and yeah, so just I was just like, okay, how does this show me your magic? How does this get outputted? So there's like a WebAssembly um, VS Code extension, which I think you have to. I don't imagine it's installed by default.
Oh, nice.
This is called WebAssembly, and so if you just like click on the file that it's generated, it's just going to say, yeah, it's a binary file. It's not text file, and VS Code likes
Mm-hmm.
text files. So once you install that extension, you can go down here and say show WebAssembly, or you could save it as a separate WebAssembly text file.
Oh,
So it's the same
nice.
thing. Either save it
Yeah,
as a
yeah,
text
yeah.
file or just see the text in VS Code. And so that's what I see here. And it
Oh,
sort of
nice.
looks like assembly. Um, yeah, so it's like, oh, okay, this is a bit more low level, but you can actually, if you kind of look at the this code here and this code here, you actually, obviously the names and stuff have come through. So, um, so what have we got here? We've got module, so it's WebAssembly module. We've got this idea of a type. So it's sort of
Mm-hmm.
like TypeScript. You have to have it's a WebAssembly typed language. So what it's actually doing is saying like basically all these functions have the same signature or the same shape.
Right.
They accept no arguments and they return a float
Uh,
32. And so that's what this is basically doing. Hey, it's a type of a function that's going to just accept no parameters and return a float.
if you close the Explorer, you could put
And
those files side by side,
oh yeah, that's a good idea. Yeah,
so you don't have
great
to
idea.
jump jump back and forth.
Yeah, great idea. So, and like I think it's probably pretty clear, but I may as well just like do it. I'm pretty sure I had this somewhere. Like, let's just turn this into JS. So like, um, I think that looks right. And then we're going to do the same for
Oh,
these ones.
export const.
Ah, yeah, true. Yeah, I find it hard to switch context.
It
Um,
is easier to
so,
watch. Let's see.
so it's yeah, I think. Oh
Oh,
yeah.
equals
So I need
equals.
to make this, and I need to make this a PS file. Oh yeah, and yeah, of course, needs to be equals. So that's how some people might write this in JavaScript. Um, I don't know if I'm old fashioned, but I actually prefer the explicitness of this sort of style. So it doesn't
Oh,
really
me
matter,
too.
but it it just sort of highlights to I think that this thing's going to be a function. So so yeah, there it is as like TypeScript. And so, if you're familiar with TypeScript, I imagine this is pretty intuitive. So I'm just going to put the TS file on the left, and that's your Rosetta Stone for like
Yep.
TypeScript to Zig. You can see it's like very, very similar, really.
And
You know,
it might be worth noting that there's a language called assembly script, which is a
yeah,
subset of JavaScript that, pretty much given what you have in this TypeScript file, would compile to the similar looking WASM. Uh,
yeah, that's right. I've explored it a tiny bit. I probably should explore it some more. I think it's surprising to me that that even works because TypeScript is such a different model um, to a Zig or a C. So I'm like, wow, how did they make that work?
there,
Um,
the type
but yeah, I think if you
annotations are like int 32 in. float
Yeah,
64 kind
okay.
of
So you
thing.
do in 30.
So you are thinking
Yeah,
in
okay.
that
You sort of do
like
this.
in that headspace.
Yeah.
Um, there,
Yeah, and I
I
think
think
if you just sort of do work with primitive numbers, and it should, yeah, it should just work out. But that was when I first heard that project. I was like, wow, that just works.
more. I don't know if absurd is the right answer. Is I forget what it's called, but there's a JavaScript engine called QuickJS, which can be compiled to
Hmm.
WASM, which means you
Hmm.
can run JavaScript in WebAssembly. um,
Yep.
as is. So I forget the name of that particular project, but that's also a thing that
Yep.
you can. So like,
Yeah, it sort of shows you that your WebAssembly is pretty uh, is a true assembly. Like you can, it is this general purpose language.
yeah,
If you to write quick JS from scratch in WebAssembly like this, it's going to be horrible, but it's like it's possible.
yeah. I'm sure it's written
um,
in like C or something, and they're compiling it to
yeah,
WASM. But
yeah, yeah, it is.
just
Yeah.
another weird one is you could run interpreted languages in this. There's for sure an overhead to doing that,
Mhm.
compared to C or Zig that are have very explicit memory uh, definition, like
Yeah, just
ways
I
of
assume my
handling
screen is
memory
still.
that coincide with the way WASM works.
Yeah, I assume that my screen's still being shared.
Yep.
So just to make this a bit more visual, yeah, quick JS ballard.org, and there's an online demo at numcalc, and it's the C. It's written in C, just a few C files. Um, yeah, they just compile it to WebAssembly with mscripten, which is basically a tool to do that job. C to existing C to WebAssembly, just make that happen. So that's pretty amazing. Um, what was I going to show? I've forgotten. I was going to show another link. Oh yeah,
Oh,
Pythonide, something like that.
I'm not surprised that
Pythide, yeah,
someone would have done this.
Pydiide. There we go.
Someone would have done this for Python as
Py,
well.
Pydiide is Python. Basically, it will just work magically in your browser or Node.js based.
Mm.
Yeah, it's using power of WebAssembly. So you've got this hugely highly dynamic language like Python, um, and they're able to compile it to WebAssembly. And then once it's compiled to WebAssembly, it just works in your browser. So like that's pretty amazing to be honest. And I'm pretty sure. What's I'm gonna blank on the name. The what's the SQLite? Um,
WASM
not an ID. What do you, no, there's a
playground. Oh, the
SQL.
playground.
Yeah, you can. There's a SQLite playground. There's also. Why am I blanking on the name? It's a really interesting guy. He's talking about AI sort of stuff a lot. He's
Mm.
heavily in the Python community. Like blanking on his name. Um, I often I subscribe to him directly on his feed in here. So probably Simon Wilson. The Simon Wilson, if I can remember how to type one. Simon Willison. So he creates a thing called Dataset, which is really popular. And he got
Oh.
Dataset. Not sure if I'm going to be able to just autocomplete it off the top of my head. But he made that's usually a tool like you pull it down, you can run it locally. It's Python. It has to be web server. He made
Mm.
a version of it that works just in your browser. So you can basically turn any. He got the existing Python code base, which had probably been he'd worked on for like 5 to 10 years or whatever,
Wild.
and sort of crossed his fingers and hoped that it'll just magically work in the browser. And I'm sure it took some effort, but yeah, through died, he got it to work. So
Wow.
yeah, it's pretty amazing. Um,
Yeah, it's
yeah,
so
that,
interesting. All the things that were never meant to run in the browser can now, I don't want to say seamlessly run in the browser, but with minimal effort, maybe
Yeah,
People could probably speak to that
yeah.
better than me, but it's pretty wild that you can like
I mean,
just get
he's
that working.
amazing. He's a gun. Like I recommend following his blog because he's just like
Okay,
so productive and so open, which I really like, and just skips so much stuff. He's just worked at. He's just very productive, but very generous as well, which I like the vibe. But yeah, pretty. I'm not sure if it's sort of going into it, but yeah, I thought it used Pio died. Don't know, but yeah, there's a version of dataset that basically just
gotcha.
magically boots up it in your browser. It's almost like it's
Cool.
emulating it.
So going back to
Um,
that WASM file
yeah,
in VS
yeah,
Code.
yeah,
Um, we're
yeah.
I
So,
sort of mentioned before that WASM sort of just has like a couple built-in types that are all in floats. Is correct?
yep,
Um,
yep, yep,
so that
yeah.
means
So
that
there's,
any given function, let's say a function returns a string in C or in Zig or whatever you're writing in WebAssembly, that
yep.
is converted to a list of numbers. I don't even know if lists are like a first class thing in WebAssembly. So how does that work if like conceptually like a function returns a struct or a pointer to an array or something? How does that all
Hmm.
work when it gets compiled down to WebAssembly, which like might not support those types, and how do you consume that in the host language? I think that's the biggest question I have in this, as of like the past couple of days that I've been moosing on and trying to figure out.
Yeah, so I think that's I had the exact same question, and that's what the sort of repo is sort of exploring.
Mm.
And I'll just finish walking through this quickly because it's just
Oh, for
so you've
sure.
got this idea of a F32 const, right? But yeah, as you're sort of alluding to, like how do you get bigger than an F32 const? Okay, I can do like I could change this to F64. Okay, it's in read only mode, but like this could be F64. But
Right.
if I want to have something that's like two F32s or two F64s, like how do I represent that? And you kind of find out that it's pretty limited in what it can do. So yeah, that it's so yeah, and hopefully I'm showing like this WebAssembly, like it looks a bit alien, but like it's pretty friendly. And I think if I can just, I think it's helpful just to map this stuff uh,
Yeah.
to TypeScript because it's sort of showing like it's not really that different. Um, so if I looked, so that the we had the Z one, I showed you how it sort of mapped to TypeScript. Then I'm looking at like what the Zig compiler like output for that WASM file. So this
Mm.
Zig file outputted this WASM file, and then sort of like going a bit backwards and going, okay, well it decided to inline
The cons.
these numbers, so I'll just do the same here. So it sort of matches up. So I've removed the exports, and then you'll see that like, oh, okay, I'm going to export pi and export answer and export negative answer,
So
and
what's
like
out
that's a
global
perfectly
there?
valid.
What's that? Line 10 and the memory.
Yeah, so you can see how these match up. So yeah, we've got this idea of a type. We've got three functions, which is good. We sort of would hope that we'd have the three functions. There's the three functions there. And then we're going to export these things. And so yeah, once you've sort of seen how that sort of maps one to one, yeah, you will notice like, okay, but it's got this extra stuff here. What is that stuff? So yeah, you've got these like primitive values, but as you were alluding to, like you that's going to be pretty limiting if I'm just everything's an int or a float. Like,
Mm.
okay, how do I even represent a string, some text
Right.
using that? So that's what this memory thing is. So WebAssembly gives you like a big buffer, like a big array of like bytes called memory. And so it's very similar to like just like RAM memory if you're writing like a
Right.
C program or any program like that. And so it's Zig is usually going to be used in a context where you're going to make use of that memory. So it's actually exporting memory, but the size of the memory is 0. So this line is kind of like useless.
If it was a
And
real program,
then
it would
actually,
request.
sorry, I've misunderstood that. It's sorry, it's the memory size is actually defined here. So it's defined this
Oh,
memory,
okay.
and then these are just referring to these as like the first memory, and so this is the first
Ah,
function, this the second function, the third function. So the second function's here. That's what this comment is. So yeah, sorry, I've just confused myself. So it's putting aside this amount of memory, 16 um, big blocks of memory called pages, and so it's sort of going to assume that you're going to need to use that to have a compile like normal Zig code that does a bit more than just return three numbers.
right.
Um, so yeah, that's what this is. And so it has this big sort of memory, 16 pages. And so this 16 pages, one page is 64 kilobytes. So that's, you know, 65,000 bytes. And then
Right.
you're going to times that. Zig's chosen to have 16 of those. Six basically gives you a megabyte of memory.
Okay.
So yeah,
So when a WASM module comes into the browser, it's requesting a certain size stack.
yep.
Um,
Yep. Yeah, so it's requesting, okay, yeah, I want basically, yeah, 16 times 64 times that 1 megabyte of memory. So Zig
right.
just goes, that should be enough headroom to do pretty much most programs. And
Mm-hmm.
so it could have been more conservative here, but I think they've just sort of learned, or they're just sort of taking a stab and going, yeah, 1 megabyte should be enough.
Are you
So
able
if you've
to
used like other,
increase that size if you run out?
I think so. Yeah, there's
Okay.
probably some flag to increase it, but it's sort of like if you've used like Lambda or like one of these like cloud hosting platforms, like with
Mm,
Lambda, you have to say like, how much RAM am I going to give this thing? So it's like, even though it's this like magical serverless thing, there's still like limits there. And so like WebAssembly um, is is still magic. It's sort of low level, but there is magic, but there are also hard limits. And so yeah,
mm.
okay, it has to come up with some. Yeah, 1 megabyte of memory. Okay, that should be, yeah, that's the limit there. So that there's the memory. It's going to export that memory so the outside can read that memory. So it needs to export it so
S-
there's sort of a bit of back and
Uh,
forth. So if I have like a string, I'm going to want to read from that from the memory. So you could choose not to export it, but usually you're going to want to make that public. So you're sort of making your whole memory public. But that's
uh,
you with WebAssembly 1.0, like that's the only choice you have. So that's what it decides to do. And then you've got this weird thing here, and that's basically a stack pointer,
mm,
which, and you'll notice that we did the calculation there of 16 times 64 times
right.
1024, and you'll notice that
Mm-hmm.
1048, 576, 1048, 576, it's actually pointed to right at the end of the memory. And so this is getting a bit into the weeds, but um, basically Zig will have the concept of a stack, and it's going to like decrement that number. And so this is like a little pointer. That's the stack pointer that's going to like control where in the stack we're currently at. So it's going
Uh,
to just sort of go, okay, I kind of need these three things for most Zig programs, even if it in this case it's not necessary here. So they're going to come for the ride. But yeah, so you can sort of see like that. And so yeah,
so
that's
memory
what you
here is
that's what
that's used as both the stack and the heap. Is that
well,
true?
that there is no stack or heap. So in a C program, you've got this concept of a heap and a stack. Maybe I'll switch back to
Like a ling like something compiling to WASM, like in C, like there's a stack and a heap. This memory block is what's used for both of those.
that's right. Yeah.
Okay.
So with C, you've got this concept of stack and heap, but it's sort of an abstraction.
Yeah.
So even though it's like fairly low level, it's actually still an abstraction. So often what you do is it's the same concept. You get pages. So you get pages
Mm-hmm.
from the operating system. And so your C program under the hood is actually going like, hey, operating system, give me 16 pages or however,
Right.
what depends on the page size, but give me 1 megabyte of pages. And then I can choose to use that however I like. And
Ah,
then in C, you have this like concept of the heap and the stack. But basically, they all just live in the same space, and so that's why like Stack Overflow and stuff is such an important thing when it crashes because the two can actually because they're all just in one big memory space,
right.
they can actually theoretically overlap. So it's just sort of got this big bunch of memory, and it's gone. Okay, this spot in the memory is the stack, and then the rest of it's going to be the heap.
Mm.
And so you can sort of see that leaking, not leaking through, but you can sort of see that shining through here. Like Zig's kind of done the same thing. Um, yeah.
And
So
so if
yeah,
let's say there's a function that returns a struct,
yeah,
is it
yeah,
returning a pointer to a spot in this memory, and then something is able to figure out how to serialize that into the host language? Is that, am
yeah.
I
So
reading
that's the
that
exact
correctly?
question. That's the exact question I had, and that's why I created these little programs to sort of see like, okay, um, here's let's do something a bit more complicated. Let's clean up my beautifully managed code. I'm going to like convert a float to a string.
Mm-hmm.
How, okay, I can write that in Zig. I can get it to compile, which means like it's happy with the code, but then like what does that look like at the other end? And so um, I think in this case it looked like it just failed. Might be I think I had some issue with like cache invalidation, but let's try and get that to compile. Um, And if I generally find like the Zig compiler, its WebAssembly support is pretty good, but it can be sometimes a bit new. There we go. Um,
Okay, a little more
so
going on
sometimes it's a
here.
bit flaky. So
Yeah.
this is quite interesting because one of the things I've found on this journey is like float to a string should be like really simple, right? And so I'm like using the standard library from Zig and it's like delegating to its ability to
You're pulling the
turn a
standard
float.
library, or the parts of the standard library you're using into here, right? That's what we're looking at.
Yeah, and so it's like, turns out to turn a float into a string is like a huge amount of work, and there's multiple papers on how to do it, and there's multiple opinions on what the best way is, and there's a lot of code to do that. So that was one surprising find on this journey.
Mm.
Turning an int to a string is a lot simpler. Maybe I should just show that, but yeah, you can start to see like, wow, okay. There's a lot here. I think if this is the other function here, I think. No, that's still the same function. Trying to maybe I'll comment this function out. Let's get rid of that one and I'll compile it again and hopefully we just see this one and it should be a lot simpler.
Yeah.
What is that?
Oh, much
There we go. That's a bit. I can breathe now again. So I don't know what this is. I think this is sort of it somehow putting the binary format, but I think
yeah.
that's just the VS Code plugins fault. So yeah, let's look at this code. Is valid file name. So all it's going to do, basically a valid file name is um, if I have tried to save a file, I can even try and do it here. If I try and save a file like this file here, well, let's try and we'll make a new file.
So this returns a
If I try and
boolean.
if I try and save a file here, right, like
Yeah,
I
yeah,
can
yeah.
basically use every character except like one. I think it's in on the Mac, it's the colon. So I'm trying to type the colon key, but it doesn't let me type it. I can type slash, but it's probably confusing because it's behind the scenes. I think it's just the same thing. So basically, a file, anything is a file name like abc.js or txt or whatever. But if it's got a slash in it, that's used in like Unix as a path separator.
Mm-hmm.
So that's not a valid file name. So all this function does is basically go, give me an input string, and I'll tell you if it's got a slash in it or not. And so what it's doing is it's looping through all the characters, and if it's a slash, if it finds a slash, it returns false.
Hmm.
And so yeah, so I've got this sort of concept of a string, and then this is how Zig decides to represent that, which looks pretty funky. Like, why doesn't it just say like
String.
string? And it sort of turns out there's multiple ways of representing a string. And this is the one that's compatible with like WebAssembly. And so,
Hmm.
yeah, I'm just sort of being curious to know, like, I had the same questions, like, okay, but what is this thing? Because I know in WebAssembly, like, everything has to be like an int or a float. So what does this magic input get turned into? And turns out it just turns it into an integer. And that integer is an offset in memory to this memory here. And so you'll,
Okay,
this thing under the hood is really just a
pointer
offset.
or an offset, whatever.
And so there's instructions to like give an offset load from the memory, and you can store as well. So load
Hmm.
and store, basically like read and write to the memory. Um, yeah, so everything's just an int. So even a string with WebAssembly 1.0 is just an int, and that's where I think if you're learning this stuff like a learning C or Zig is helpful because you've got this sort of idea of a pointer. Um, yeah, but it's if you especially if you've been writing in a higher level language like TypeScript or whatever, it's like, oh, like, okay, yeah, it's sort of a bit of a mental adjustment.
Yeah.
Um,
And
but
then booleans are
yeah,
just a
apart
one
from
or a
that, apart,
zero, huh?
Booleans are just an integer as well. So yeah, often like in a C language, you'll have like, okay, a Boolean's going to turn into like a 1 bit or like 1 byte. But the smallest thing in WebAssembly 1 is I32. So even Booleans are I32s as well. So like in this program, like basically everything gets turned into I32.
Hmm.
So this string thing's an I32. This character that's being read is an I32. When it's doing this Boolean check, it's an I32.
Right.
This thing, this um, this index is an I32. So yeah. So yeah, I could. I don't know if it's helpful, but I could try and like sort of break down like how these things like map across. But
Yeah.
obviously, if you've
No, it makes.
hopefully this if you're familiar with like JavaScript, it looks sort of somewhat what you'd write in JavaScript.
Yeah. No. No. It makes sense to me. I'm
Yeah.
trying to think.
So yeah, that's
Ideally, we would wrap
so
up in a
yeah, just
little
in,
bit.
sure.
Um.
Yeah, yeah, of course. Yes, the time's flying by. So yeah, I mean, this is so this repo is available. So I just encourage people
Cool.
to either copy this repo and like feel free to make pull requests as well. And yeah, I just was using this as study into to try and find out, okay, how does this is a valid program, but how does it translate it? And
Yeah.
so I've even got you probably like this. I even have one for a state machine.
Yeah.
With structs and stuff. And
Nice.
then there's like all this code to do that. And then yeah, you compile it and it just turns it into ints. It's surprising.
Pretty wild.
Um, um, so yeah, there's a yeah maybe it's I mean if you're up to it, happy to do another part because yeah there's a fair bit here. But this is like WebAssembly 1.0, and so like WebAssembly 1.0 is primitive because you do just have integers and floats. And then that's where those proposals that you're talking about are going, okay, well, to make Kotlin's a popular language that they're really using
Mm.
to like battle battle test or like not
Yeah.
prototype, but like they're trying to use that to inform how where WebAssembly like 2.0 goes.
Yeah.
And it's gotten a lot richer, larger. It's gotten a friend told me it's not really assembly anymore because it's such a it's this is if you look at like normal assembly like this you squint and it looks like it. The new stuff it's way bigger in size and scope.
Mm.
um
Really.
because because Yeah, because sort of turns out when you have these richer objects, you have to sort of think about, you have to start managing them. Um, and that's where, okay, if I return a big struct or a string or something more complex, okay, like there's no sort of concept of like this 42 needs to be garbage collected or this 3.1
Yep.
blah 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 needs to be garbage collected, but like richer objects do. Um, and so that's why you have that the garbage collection proposal with WebAssembly. And it turns out that that's why it's taken a while because those two things are sort of related. If I'm going to return richer structures and I need to like manage their memory somehow, like need to free their memory because otherwise they'll just be memory leaks. And so that's
Yeah.
why those sort of two proposals got spun together,
Mm.
and it's taken a while to sort of bake in the oven.
And then my understanding that's actually interesting because what I learned a couple days ago was the component model for WebAssembly is pretty much taking a WASM file, a WASM module, and then annotating the exports and the imports with types using a format called WIT. Um,
Yeah.
I don't know anything more specific about that, but they were talking about like how do you represent strings that it's defining the communication barrier between a WASM module and a host environment or another WASM module, and they need rich richer types to scale
Yeah.
that, including strings and bools, and lists as well.
Yeah.
Uh, so yeah.
Yeah. So I'm just showing just showing this on my screen at the moment. Like if you look at WebAssembly 1.0 spec, here we go. Probably can get 1.0 or 1.1. If you look at the different types, I think it should just, it's a spec, so it's not always the most friendly document, which is annoying.
Text format
Numeric?
types
A text format with,
down a
yeah.
little bit. Types probably. Yeah.
Yeah, so here we go.
Four
So
types.
yeah, WebAssembly 1.0, like, okay, you just gave me these four things, and technically with the compiler like Zig or Clang or whatever, it can do the job, but
It's a lot of work.
it's gonna have to um it's pretty primitive what you've given it. And so yeah, like you're saying, it'd be nicer to have some richer types. And so that's you can see the ones available are starting to get larger here, including strings and booleans and stuff. And it gets even larger because it's like, okay, we want to have like an array of bytes.
Hmm.
Um, we want to have things that are optional. We want to have these like result things. We want to have tuples. We want to have records. Like we want to have like
They're getting, yeah.
also called
It's
structs.
it's growing.
So yeah, it's sort of like once it wanted to go a bit larger than just these four, it escalated pretty quickly. Um, and that again, that's why it sort of had to take a while to bake because they have to make sure all this stuff works. Like, okay, I'm gonna have a record and I want to be able to put a list in it and
Hmm.
nest compose all these things, and then like you're saying, like export those things so the outside world can read them. Yeah, this I haven't digested this spec fully. I don't even feel like I've digested the 1.0 spec. I'm just sort of trying to get everything in here
Yeah.
in orb, but my feeling is it's like at least doubled, tripled, quadrupled the size
Oh,
um
it seems
of
exponentially larger now.
yeah. So it's I think it's both a good thing, but it's also I'm a little bit worried because then that's kind of it feels like the web stuff goes and like, oh, I'm going to try and become an HTML expert. And it's like, well, did you know about this tag? Like, it's just the web specs are just going to forever grow, I think. So I'm a little bit worried that this train's going to just keep going forever. But
So my understanding is, and again, I'm not on the standards body or anything, but my understanding from what
yeah,
some of the people on the standards body were saying was uh, now that the component model and WIT and garbage collection and WASI 2
Hmm.
have all landed, meaning that there won't be any breaking changes for a little bit. Um,
Hmm.
what they're moving to now is a lot more, as you were sort of saying, is moving really slowly because there's all the serial work that they had to do. Like we need to do this and
Hmm.
this and this, and there wasn't a lot of concurrent work. But now that a lot of this stuff is landed, um,
Hmm.
its goal is to stay, you know, is to start going towards stability. And I think they were saying there's some concurrency stuff that they were doing about adding promises and maybe like observables, like there's some concurrency like work that they're looking into, and then after that, WASM like won like the full set of
Hmm.
specs will hit land, and they don't really expect changes to happen for like 10, 15 years kind of. So I think that's sort of the
Oh,
headspace that
okay.
they're in, that they've been doing a lot of work for the past like 8 years to expand WASM so it's useful, and
Mhm.
we'll see how stable it is. But there's a little turbulence right now, but hopefully it stabilizes. That's my understanding of how they're approaching it.
Yeah, okay. I think that sounds good. I think if you look at the history of any programming language, I think they all try and imagine that's how it's going to be, and then they find out that
Yeah,
it's there's a better way. There's always a better way. So I'm sure that's just the way. That's just the nature of this stuff.
for
So,
sure.
but snapshotting the understanding of like 2024 programming languages and what you'd want to have in one sounds pretty great. But I'm sitting in 2024, so there'll probably be developers in 2040 going, God, why did they do that? Just like how if you
Yeah.
write Java as it was in the 90s, you go, oh God, do I have to do it like this? But yeah, I think that sounds promising. I'm a little bit worried that um, as WebAssembly gets popular, not saying necessarily some of those things are bad ideas, it just increases the complexity. And
Yeah.
I really just like the simplicity of it. So some of these sync stuff, some of the promise stuff, there's all, sound like a cranky old man, but there's all trade offs with that stuff. I don't think looking at some of those things as silver bullets, I think is a bit, um, yeah, I hope I don't know. Yeah, like I don't think you need promises or currency support to be able to support it today. It's just that you would have to model it a bit differently. So maybe it
Yeah.
makes sense to have it as like a built-in primitive, but yeah, if you get that primitive slightly wrong, then it's going to be forever, and yeah, that kind of is a bit limiting. But yeah, yeah, they have to settle on something. But I just yeah, I hope it's not going to be hope trying to learn WebAssembly is not just this enormous PhD level task.
Yeah. I guess for you, creating something that compiles to WebAssembly, the great thing is these changes are opt-in. Like if you want to stay in,
Yeah,
in
exactly.
float
Yeah,
world, you can. You don't have to use these new primitives
yeah.
if they make things more complex for you. So I think that's an important part of the standardization process that WebAssembly is in. Of
Mhm.
besides like the previews, once things settle, they settle and they don't break, and it
Yeah, that sounds
forces
good. Yeah,
additive
I
things, and you don't have to use those new things if it's causing you more pain than helping you.
yeah, we haven't really talked about orb much, and yeah, probably do want to wrap up. But yeah, one of the philosophies I have with that is that it will orb. I'll just open the repo.
Yeah, let's do
Um,
5 minutes, and then we could always dive in the or. Well, this will be a multi-part thing. I have a feeling. Um,
yeah,
as I dive deeper into it, I'm sure more questions will come up. But and we could totally do a whole thing just on orb and what you've been exploring here as well.
yeah, sure. So the orb is basically so when we're looking at VS Code with that what syntax, it's basically a way to make that what syntax more friendly and
Mm,
composable. And so like you saw the massive output of the float to string stuff.
yeah.
And it's like, well, I could write the WebAssembly text syntax, but it's pretty low level, and I'd prefer not to have to copy and paste like it's the 1970s.
Yeah.
So yeah, I've just sort of chosen this language that I like, and I think it's which is called Elixir. I think it's quite good for the sort of DSL style stuff.
Mm.
So it's been a great sort of
So
base language to build this to base this on. But you can see here, like basically, you're gonna try and author a thing like this, and then I give you hopefully
gotcha.
more friendly syntax like this.
So you're sort of using macros to
Yeah,
compile your
it
DSL or better notation to watt. Is that in
yeah, I'm
Elixir?
trying
Okay.
to do yeah, trying to use macros. And at the start, I think there's a lot more macros, and I'm trying to actually pull out as many as I can because I want it to be really simple. Because basically, I don't want to create another programming language. I want to have the same semantics
Yeah.
as that WebAssembly gives you. So in terms of just because the reason why this triggered in my mind is talking about the spec is that I think WebAssembly, the orb will let you give you the primitives, and even like it'll be extensible.
Mm.
So it'll support WebAssembly 1.0, but like supporting WebAssembly 2.0, like with the
That's gonna be a lot of
BC
work
garbage collection
for.
stuff.
Yeah.
There's going to be a lot of work, and so I actually want to make that like I don't think I'll have that built in. I think you'll be able to plug that in yourself. So I'm hoping that will be a community effort, and so we
Mm.
can all work on that together. But it won't. That can um, this thing's sort of an extensible base. Um, so essentially, what all that means is that it will come with some primitives out of the box, but the ability to spit out the syntax, the what syntax or the WASM binary format, is you'll be able to conform to that protocol. Like you'll be
Mm.
able to plug yourself in, and so yeah, that's where I hope this sort of stuff can be incremental. Um, yeah, it's pretty awesome. Yeah, I guess we should wrap up, but yeah, I guess I wanted to say like why I find WebAssembly so exciting.
I love that. I'd love to hear
I,
that.
yeah, I think it's just like it's just I think I've written it here, but it's just such a fundamental technology, and it works everywhere. Like obviously works in the browser, and like that's actually a massive. If it didn't do that, it would be a massive blocker.
Yeah.
But you could plug these things into like the server, the cloud, the edge, what VR headsets, whatever. Um, and so I think it's just going to be like a fundamental technology, like technologies we probably take for granted, like HTML or JSON. Like I think it's just going to be like one of those, but more powerful. So that's kind of why I want to learn it and contribute in some way. So yeah,
Yeah, I love that. I learned that they're also working on a WASM a registry, an npm like registry for WASM modules. That's also in the works. Um,
yeah, okay. There's one existing, and I think that person I've seen on Hacker News got a bit of flack for maybe trying to get some territory too early with WebAssembly. So I don't know if that's the same one, or if there's another one, but
I think it's coming
um,
from the standards that Bytecode
oh,
Alliance.
cool. Oh, sick. That's awesome.
So it's going to be more
That sounds awesome.
not like a single person, but it's more like a open supporting
Awesome.
organization that's building that out. Uh, like maybe I don't know if it's a
That sounds
nonprofit,
awesome.
but yeah.
Yeah.
So that'll
Yeah. I
yeah.
think, yeah, it's going to be, I think, yeah, it's going to be pretty exciting space. Yeah, it's going to be awesome.
So I'm super excited about it as well, and yeah, I appreciate that we were able to hop on and start working through it and understanding the landscape a little better. We definitely have a couple more, a lot more topics to cover in the future, and I think there's some
Yeah.
things we're still catching up on as well. So we'll see how it goes. Um,
Yeah, cool. Yeah, and I'm happy to go into orb or go into like how state ML might might write that compiler or whatever. But yeah, this is really fun
yeah,
actually.
I've been scaffolding out. We have a C, we have a the compiler written in C. I've just been working on learning and scripting and figuring out how that
Hmm.
works. And so yeah, there's s- some learnings to a lot of learnings
Yes.
to have there. So
Yeah, cool. Yeah, I'm
I'll
hoping
probably be
M
reaching
scripting
out
is
more.
not the. I'm hoping M scripting is not the webpack of the WebAssembly word
Oh,
of
I
it.
know.
Yeah,
That's
yeah.
my
It's
biggest
there's
worry.
some of this tooling's some of this tooling's amazing, but it can be more complex than the thing you're trying to actually do. So yeah, that's yeah.
Exactly.
We can't complain. We live in an awesome time.